beginning, God created the heaven and the earth. And God said, "Let the waters bring forth abundantly the moving creature that hath life." And God created every living creature that hath life. So vivid was the biblical account of creation that up to the 18th century, the concept of an unchanging world was fixed firmly in the minds of Christians and most scientists. Using the Bible as a record of time, theologians had calculated that the earth was very young. One professor had actually pinned down the day of creation at 9 o'clock, October 23rd, 4004 BC. Because the period of creation was measured in a matter of 6 days, most scientists accepted as fact that the original forms of all living things were created at the same time. Taking the Bible as his guide, the idea of a perfect world designed by a creator would be powerfully argued by one Bishop Paley. Imagine, he asks, that you had never seen a watch. You would have to assume this intricate object had been designed by an intelligent creature. Now, look at the human eye. Anything as perfect as this lens could not have evolved on its own. Indeed, anything as complicated as nature must have been designed by a creator with a purpose. Behind his purpose was an order of being made to serve him. Fixed and unchanging, all beings were ranked in ascending order. From the lowest forms of being to the highest. This divine ranking was called the Great Chain of Being. However, by the mid-18th century, there was one naturalist who saw a different pattern to creation. Carl Linnaeus, concerned as much with earthly matters as heavenly, compared living things according to shared characteristics. He divided plants and animals into orders, families, genera, and species, and provided the basis of today's expanded taxonomy. Linnaeus used genus and species to identify and name an organism. His taxonomy, still used today, prodded scientists into looking at things very differently. If species were related through genus, could species have evolved from some form of prototype? The question caused the creation model to creak a little. During this period, there was another assault on the notion of divine or special creation. The newfangled microscope, coupled with crude experiments, would reveal some serious flaws in the theory of fixed species. Believing that they had carefully sterilized their flasks, scientists boiled up a meat broth, only to observe days later a soup crawling with organisms. These results seemed to suggest that life could arise spontaneously from a mix of organic material. Enter at this time the Comte de Buffon, who, using this erroneous information, came very close to formulating a modern theory of evolution. After the Earth had cooled down, he speculated that from the primordial mix, basic ancestral life forms arose spontaneously. As any one of these ancient forms, such as the cat, migrated about the Earth, its basic form would be modified by the creature's response to its environment. The original form, acting like a template, gave rise to what Buffon called degenerate types.
Pardon?
Buffon had hit upon two very modern notions. A species could diverge from an ancestral form, and a species could be modified by the environment. But there was another contemporary of his who saw in the pattern of nature progression rather than regression. Lamarck believed that each type of life form is the result of spontaneous generation. Beginning as a microscopic germ, the life form is driven by a need to become complex. Modification takes generations. Because the amphibian is simpler than the mammal, it must have had a later start. And lower forms later still. As for simple forms that abound, they would have originated quite recently. In Lamarck's scheme, living things form a hierarchy, similar in many respects to the chain of being. However, each type of organism advances separately and continues to do so. But if his theory of parallel evolution was going to stand up, he needed a mechanism to explain how species could be modified. The mechanism he proposed was the inheritance of acquired characteristics. Imagine a herd of hungry giraffes. Now, one giraffe wishing to reach the food in the higher trees would have to stretch its neck. This constant effort to stretch its neck would affect its anatomy. When this creature with the longer neck bred, it would pass on the characteristic of long-neckedness. The offspring, in turn, would try to stretch its neck, until over generations, giraffes would take on elongated necks. Conversely, if an animal had no occasion to exercise a particular organ or appendage, over generations the disused appendage would wilt away. Lamarck's theory, whereby habit modifies form, strongly influenced scientific thought. And it still does today, because its appeal rests with the implied idea that evolution is directed. There is a strong conviction that evolution is not a matter of blind chance. Life is guided by an inward drive, which propels an organism towards a higher form. A few scientists detected more mysticism than hard fact to Lamarck's theory. Besides, if the Earth were merely a few thousand years old, how could a species evolve in so short a time? Nevertheless, it was the pioneer work of these scientists in the early 18th century and 19th century which set the stage for this revolutionary thinker whose speculation about the modification of the species would trouble paradise.